So good evening, everyone. Thank you to VJ and TJ, I think that's a first, for having us. We're really excited to be here to share some things that we've been looking into with regard to React and server-side rendering. Some of you may have been hearing about server-side rendering and might be curious about how to do it, why you might want to use it. Maybe some of you have actually written server-side rendered applications before, and we're excited to talk to you a little bit. We're going to talk to you in two segments. We're first going to give you some background on server-side rendering, why and how you might want to use it, and then we'll move into talking a little bit about an open source library that the five of us worked on together to improve some of the performance, of server-side rendering with React specifically. So, quickly about us, we're a team of developers who have been working on projects for the open source community, and a quick round of names.
Yeah, I'm Annie DiFiore.
I'm Zihao Li.
I'm Mejin Leechor.
And Stephen.
And we were pretty excited about taking on a project with React because for some of you who are here with Learning Fuse, I know that that's on your curriculum. We're excited about it as a fast-growing JavaScript framework that's pretty incredible at building user interfaces and making reusable modular components. We think it's a great framework for the front end, and we think it'll be around for a while. So, so that's where we've been focusing most of our time and energy.
Yeah, I'm starting. So can I get a show of hands as to who has done client-side rendering with React applications? Oh, okay. So we all know about how client-side rendering works. Before we dive into server-side rendering, I was just gonna give like an overview as to how you client-side render. Despite the fact that all you guys know how it works, so I'm gonna do it for the camera. Basically, this is how client-side rendering works, right? Your client makes it. Your client makes a request to the server for the SPA, and what do you get back? You get back a simple HTML, right? And then inside the HTML is going to contain a script tag, and here it's going to be it's the bundle.js script tag right there, asking for the bundle.js. And so once the client gets the HTML, it's going to see the script tag, and it's going to go send a second request to the server for your bundle.js, which is the file that contains all your React source code. And so once the client gets that React gets this front-end source code, it's gonna parse through it, and it's gonna start building your React components. And then it's going to make additional requests, send additional requests to the server for any additional information if needed. And that's just like a simple overview as to how client-side rendering works.
So let's take a moment to talk about some of the benefits and drawbacks of client-side rendering. So client-side rendering is the default method that we have for rendering our React applications, and there's a good reason for that. So as many of us might remember, client-side rendering wasn't always king. Back in the early days of the web, almost everything was rendered on the server side. So a user would navigate to a website, the host server would then send back static HTML and assets to the browser. And as you can imagine, back at that point in time, websites were much less interactive than what we're used to right now. So in order to get more information, you would usually click on a link and be directed to another page within that same site. So you'd be triggering a full page reload. Now we don't live in that era anymore. We don't expect that anymore. This is the era of full-blown JavaScript applications that run in the browser. And so they provide quick interactivity. A user expects that if they click on something, something will happen, something will animate on the screen. So the very cool thing about that is that you're not seeing you're not triggering that full page reload. There's a sense of that website being dynamic. But that also brings us to one of the big downsides of client-side rendering. So how many of us have seen one of these in recent memory? with client-side rendering, what's happening is we're front-loading so much of that data and interactivity, and as Z just explained, you're seeing multiple round trips from the browser to the server to grab the HTML, to load up the JavaScript, to bind the event handlers, and that's before any content is even viewable on the screen. And that wait time can actually be pretty costly. So imagine that you've got an e-commerce site and your users are navigating to that site and have the option of going to a competitor's site. And if your very slick React application is taking some time to load, that's a potential loss in your conversion rates. That user who is perceiving a slow loading time for that website because that JavaScript is still loading up, may navigate away. So it's just a matter of seconds, but those are valuable seconds. The BBC actually reported that on their website, they lost about 10% of their user base for every additional second that it took for their website to load. And there have been other statistics about that out in the world. I think back last year, it's something like 19 seconds on average for mobile 3G websites to load on phones. So anyway, what we're seeing are that a lot of websites that are taking too long to load are losing their users, and that is a hit in perceived performance. And the other place where we are seeing some suffering with the client-side rendered applications is with search engine rankings. So with that initial sparse HTML that you typically have with your React applications, there's just not a lot for web crawlers to work with. Now, there are ways to mitigate that, to use third-party services to improve SEO, and also the Google search engine actually does dig into JavaScript when it does its indexing, but that's not the case for every website, or I'm sorry, for every web crawler. So if the user, so for Bing, for example, or some of the other search engines that are out there, you would potentially not be getting the best SEO that you could be with that client-side rendered app.
So what can we do other than client-side render? Well, we can send down fully rendered HTML from the server side. But before I talk about the performance difference between client-side rendering and server-side rendering, I want to give you a real-life example from Walmart Labs. So if we can see when we client-side rendered, now we have no viewable page for roughly around 1.5 seconds. And then after the page is rendered with full functionality and it's viewable. Now if we see when it's server-side rendered, we almost see a page instantly, around 0.6 seconds, and we'll see a viewable page. And then after 1.8 seconds, the page becomes fully functional.
Cool. So how do you accomplish server-side rendering in a React app? So if you have a server-side rendered React app, the initial stages of the request are the same. The browser is going to make a request to the server for the page. The server is going to fetch data, render the app in memory this time, as opposed to just sending over the sparse HTML with instructions for rendering the app. And the server, within that first round trip, is sending back the entire page, including all of the HTML, so that within one round trip, you have a viewable app in the browser. The client still has to make this second request for the JavaScript file, because when you see this first paint, you have a website that is viewable fully, but it's not interactable yet. So if you are like super fast and are somehow able to click on buttons within like 300 milliseconds, I guess you might be disappointed in the performance of this app. But as far as the user is concerned, it looks way better. Like the content appears on the screen faster. We still have to make that second request. So the client makes a second request for the bundle, and then when it receives it, it executes the bundle, which includes all of that client-side code. So inside of that client-side code, you're going to see a method called hydrate. And hydrate is adding the interactivity through two basic mechanisms. So it's adding event handlers, and it's also adding any of those lifecycle methods that you might have in your client-side React code. At this point, you have a page that is not only viewable, but now it's interactable, so it actually works. Hooray. And the important thing to note here is that after that first initial page load, if the user then goes on to navigate to another section in the single page app, any subsequent re-renders are going to happen on the client side. So it's only the first render that happens on the server side. Everything after that is happening on the client side. So you still get that fast interactivity that we love about React.
Okay. So how does one actually implement SSR in your React application? We're going to be taking a look at some code. This is the code that would be running on the server side. This is a basic Express running on top of Node. There are other implementations that can, or other environments that you can use to render your server-side rendered React app. But since we have Node now and JavaScript, we have React and JavaScript. Node is in JavaScript, so it makes most sense to have the same code base running on both the server and the client. So we're starting up an Express application, and luckily, React supports server-side rendering out of the box. If you download React DOM and import /server, you already have access to React DOM server. So that's been the case for several versions now. So yeah, you would start up your server, and you now have access to 4 methods. You have render to string on line 9, and that takes in the app component and returns out an HTML string representation that gets sent to the client. You also have render to static markup, and that does the same thing, but it only creates, it doesn't add in a lot of the DOM markup that React uses internally. So it's kind of more geared towards static websites where you don't need a whole lot of interactivity or the state never changes. So, and also you have render to node stream, which is new in React 16, and that allows you to send over the HTML as a stream. So the markup is exactly the same as render to string, but as the HTML is generated, it gets sent to the client, resulting in even faster page loads. The only problem is that a lot of people aren't familiar with streaming, even though browsers have been able to handle streaming HTML since, let's say, like the early 2000s or so. But nobody does it. I think it's just not a common practice. But it is available, and also you have render to static node stream, which is the streaming version of render to static markup. So that's it. You have 4 main methods. I would say that most people would be using render to string most often, unless you're doing streaming, which is then you do render to node stream. But for 90% of the time, I would say render to string is your bread and butter. And in the client side, instead of importing in render from React DOM, you would just use hydrate and call hydrate much like how you would call render. And that, again, adds the interactivity back to the page. But yeah, that's it.
Cool, yeah, okay, so we're about to move on to some optimizations, but just as a summary, again, why do we care about server-side rendering in React? It's these 2 reasons. You get viewable content more quickly. It's not necessarily interactable more quickly, but the perceived performance of the page is higher. And then secondly, you're improving conversion rates through the first point, but also through search engine optimization. So yeah.
Quickly before we move on and talk about the library that we worked on together, we've gotten the question before of, well, when wouldn't you want to server-side render your app? This sounds awesome. Well, there are a few good reasons why you might want to avoid SSR. There are, like any good tool, there are some advantages and disadvantages, and some of the disadvantages are, well, perhaps the main disadvantage is that it will add a layer of complexity to your application. So, for example, if you've got JSX on your server-side code as well as your client-side code, now you're looking at 2 build processes, one on the front end and one for the back end. If you're using React Router, you may also have to have two separate routing systems working at once in tandem. And you're going to have to make sure that your client-side HTML and your server-side HTML, as you've written it in React, are lining up. You also, actually one of the biggest challenges is trying to get Redux support into SSR. It is possible, but it's a tricky thing. So that's outside of the scope of our talk for tonight, but that is another complexity and maintainability issue if you're also having to deal with state in Redux. So another thing, you are now giving your server a job to do, which is to generate this markup to send back to the client. And with that additional job that the server is trying to do, that's potentially tying up your server and meaning that it may not be able to handle as many requests as it would normally. So if you have limited server resources due to budget or other limitations on scalability, SSR might not be the right approach for you. There are ways to mitigate this and ease the burden of server-side rendering on your server, and we're actually going to get to that. That was the direction that we took for wanting to explore some of the optimizations that you can bring to SSR. So just something to keep in mind. SSR is not for everything. If you've got a smaller client-side rendered app and it's doing fine, this may not be the approach that you want to take.
So before we talk about the specific optimization that we chose to build on, I just want to talk about three main categories of basic optimization. So the first one is if you're measuring the speed of your server-side rendered app, make sure you're doing so in production mode instead of developer mode. A lot of us already know that, of course, but I just really like this visual. The only thing you really need to look at is these are other things. But this is for React, and it's very small, so I'll just tell you. It says requests per second on the y-axis. So essentially, if you're running React DOM in development mode, you can only process 304 requests per second, as opposed to if you're running in production mode, 1,563 requests per second. So it's a huge difference, as you can see, based on this very cute graph. Why is that? It's because React is a very robust tool, and in developer mode, it has a lot of these very helpful warnings and console logs and just tools for the developers so that you can build a very smooth, lovely React app. But if you are deploying a production level project, you don't need those things, and it turns out that those things really slow down React. So if you really want to see your React app fly, production mode. Okay, the second thing Stephen touched on earlier is streaming. So streaming is actually an optimization that is new to React 16. There have been some other tools built to kind of patch on top of older versions of React because a few people identified that streaming would be a really cool thing to have. They didn't have it before, but now React 16 does support streaming. It is kind of something that you have to kind of take with a grain of salt because you might not always want to use streaming. The two main issues with streaming that I've come across are for one, if you have something that requires some kind of server response, your server might send a 200 status and then get an error in the background and then not be able to send an updated status because essentially with streaming you're sending bits of data as you get them, and once they're sent off you can't go back and change them. So that's maybe the biggest consideration with streaming. You want to use it judiciously. The third thing, the thing that we're going to focus on most with our talk is caching. Obviously you can think of caching as a way to make processes run faster. If you store the result of a function in a cache, then you don't have to make your server run that function anymore. So that's where we have focused our work. So we released maybe, 3 weeks ago, I just made that up, but sometime in the last month, our library, it is very snazzily named React Component Caching because it provides component level caching support for React. We built it to bring this very what we think is a high-value optimization to server-side rendering in React, and we're going to talk in depth about why we chose to explore this field, why component level caching is an important optimization, how we accomplish it, and then how you can use it.
So why component caching? Well, before I talk about component caching, I want to talk about the most common alternative to component caching, which is page level caching. With page level caching, there's a lot of cons to page level caching. So given this example, if it was this Yahoo homepage was page level, if this Yahoo homepage was page level cache, we would see the user data for Macs, and we would see the incoming user mail from Macs too. We don't want that, and we also would get data that is specifically for Macs, ads for Macs that we don't want. What we want is data coming that is user specific, not user specific. So all we want is Yahoo articles. That's all we want. So another thing about page level caching is that we wouldn't want dynamic data. If we have dynamic data, like give an example of stock prices. If we had stock prices updating, if we had stock prices updating a lot, then we would have the dynamic data wouldn't come down to the client clearly. So if we had a stock price from 1 hour ago, we won't want to cache that, because then we would have a cached stock price from 1 hour ago, and we only want the most updated stock price. So with component caching, we have the basic building blocks of our UI. And now we have components that are reusable within a single page and across multiple pages. For example, if we had like a header that was the same for all pages, we can cache that component and then send that component down to all the multiple pages.
So before we take a look at a couple of the features of this library, I want to make a brief aside, and this is related to what some folks have mentioned already about working in open source. So we're not the first folks to have experimented with component level caching. We are standing on the shoulders of work of previous open source contributors. So this is one of the very cool things about being able to work in open source, is that with code being transparent and readily accessible and available, we kind of get this rapid innovation and rapid iteration that's possible. So Sasha Aiken is one of the sort of authorities in the server-side rendering space. He's somebody worth following if that's something that you're interested in, especially with React. And he gave a great talk back in early 2016 about how you can improve your server-side rendering performance. And he sort of demoed component caching as this experimental feature. He had this recursive divs page, and he was showing that component caching could be, this is a strategy worth exploring. And not too long after that, Walmart Labs actually did release a library, an open source library for component caching. It's pretty sophisticated. And another exploration into component caching was done by this group called Formidable Labs in their SSR optimization package, Rapscallion. So, but as many of you know, back in the fall, React 16 was released with a rewrite of the core React algorithm and many updates, and some of the updates that we were talking about to the server-side rendering methods, including those brand new streaming methods. And as soon as that happened, Walmart Labs component caching library and Rapscallion no longer had support for component caching, that it was no longer working with React 16. So we were curious as a group of people who were exploring this question of, well, can we do this with React 16? Is this still going to work? So the fruits of our labors exploring this question became this library, and so we're really excited to share some of its features with you tonight. So following in the footsteps of some of those prior caching libraries, React component caching offers two different strategies for caching your React components. So the first is a simple strategy, and that basically saves a rendered component to the cache with the prop values, the actual values baked in. So that means if you're using the same component, if you're rendering it multiple times but with different props, then each of those different instances will be saved as a separate copy in the cache. So that you'll see that markup showing up with different versions in the cache. Now, as you might imagine, that's not ideal in certain circumstances. For example, Walmart, to give the example, a gigantic e-commerce site, was finding that they were not able to make use of simple caching. It just wasn't feasible as a strategy for them when they were trying to cache their products. So, so their library offered templatization, and so, as I said, we're sort of following in the footsteps of some of the cool strategies that have been employed in the past. And so with a template strategy, in contrast to the simple strategy, what happens is that you're saving rendered components to the cache with placeholder values. And in our library, we just basically used sort of handlebar style braces with just simple indexed numbers corresponding to the different props that had been templatized. And so that single cached template can be used to render that component, render multiple versions of the same component, and basically what happens is the actual props are injected back into the cached template upon render. And this means that you're going to see a slightly longer rendering time with the template strategy than you would with the simple strategy. With the simple strategy, you simply spit that HTML back and it's ready to go. With the template strategy, there is the additional post-processing step that takes a little bit more time. But because it's cached HTML and you're not actually running the render to string method, again, for that component, it is still quite a bit faster than with running render to string sort of fresh. So what this looks like in practice in our library is that we simply gave the user of our library the option of attaching a cache property to a component that we want to cache. It's just a slight bit more complex with the template strategy. You have the option of not only do you attach the cache prop, but you also add the templatized prop. And we decided to make the templatization opt-in by prop. So you simply have an array of the props that you do want to templatize. So in this example, there are templatized prop 1 and templatized prop 2. And we have both of those props named and included in this array. But we can also have a non-templatized prop that that will be baked in with its actual prop values as part of the template.
So before React 16's render to no string method came out, you would be using render to string. And how that works is that you pass a component into it, and basically what it does in the back end is it builds out your entire HTML markup, and once it's done, that gets sent to the client. With the new React 16 render to no string, what the backend is doing is that it's building a portion of your component. So you get like a portion of your HTML markup built. That's gonna get streamed over to the client, and then the next part gets built. It's gonna get streamed over to the client, and then so on and so forth. And the benefit of that is your time to first paint is really fast. You see something on the screen instantly, and that is the benefit of render to no string. The only problem with that is it does not support streaming, or it doesn't support caching. My bad. It does not support caching. However, if you were to require it in React CC, which is the library that we built, you could still use the React CC.render to no string, which does the same thing as the original render to no string, except now you have the ability to cache your components. Yes.
Can we actually go back to that? I think it's worth saying that, just reiterating that the way our library works is you use any of the 4 server-side rendering methods that are native to React 16. You instantiate a cache, and then you just pass that cache in as a second parameter. You're able to use the same 4 methods, just add in that extra parameter, and then the caching all works behind the scenes. So if we go on to the next slide, we can talk about another feature, which is that you actually have 3 options for what you want to do when you create your cache. We have a built-in LRU cache in our library, so you can just create a new instance of it here. Under the hood, it's just the LRU cache that's built on top of JavaScript implementations of like linked lists and map objects. But if you want to get like a little fancy, you can also use Redis to store your HTML. So all you need to do is use the Redis node client. You're creating a client and you're using that as your cache and then passing that into the rendering method. And then thirdly, it has the word cache in its name, so why not use memcached as well? It works almost exactly the same way. So you get your node memcached client, you make a new instance of it. The only difference here with Redis is that it requires, not Redis, memcache, is that it requires you to pass in a third argument, which is the lifetime of the object in the cache. So memcache uses a kind of like expiring cache that ejects like old items after a certain specified time, and you need to specify that time when you're using it. Cool. So if you have been deeply studying our library, which I'm sure you have, you might have asked yourself why it looks a little bit different actually than the 4 server-side rendering methods. So I said earlier you can use render to string, render to node stream, and the other 2 that people don't really use very much. But you have to use them a little bit differently in our library because our library has them returning promises, essentially. So render to string, if you pass in the app and the cache, it's going to return a promise that resolves to the rendered HTML. This is one way to implement it. You can use async await and kind of await the result of that promise before sending the HTML to the client. And the reason for that, just kind of like, why did we make that design decision? It has to do with Redis and memcached getting and setting functions being asynchronous. So kind of under the hood, when you're calling these rendering methods, they're making several asynchronous calls to the cache. Every time you hit a component that has a cache prop on it. And when you do that, we kind of ended up having to restructure the stack and the API to make it so that the entire thing was promise-based. So it's a promise-based API.
So we're about to close out, but before we do, I just want to point out one final thing, which is that in exchange for the performance gains that you get from caching, well, there always has to be a cache or a trade-off, right? And with caching, there are some risks and challenges, especially in the area of maintaining that code. So I gave the example earlier of using a simple strategy to cache a component, and if you're consistently rendering that component with different props, you might explode your cache, so to speak. You might have that cache ballooning with many, many different copies of that component, of that component's markup, and then you're losing out on the benefits of caching. You're basically inefficiently creating all of these additional copies. It's additional work for the server without much bang for your buck. And a template strategy also has some of those risks as well. These issues might seem trivial, but basically it just means that the burden is on the developer. If you're going to do something like caching, you have to make sure that you're using it judiciously and that it is the right tool for the job. But if it is the right tool for you, you can see huge performance gains just in terms of rendering speed and lighten up that load on the server. It's more work, it's faster. So that's all we have for you for tonight. We just want to say thank you again to Vijay and TJ for hosting us here, and thank you to all of you for giving us your time and attention and giving us your evening to spend with us. We'd love to chat with you after the talk, but any questions off the top of your heads at this moment?
Hey, I'm Vijay. Thanks for coming to the meetup today. I'm the organizer for JavaScript LA. I wanted to just personally thank you for watching this video. If you found it useful, I'd love for you to subscribe to our channel. We're slowly but surely making lots of little video content for you guys to enjoy and soak up, especially if you want to get better at programming. I'd love for you to be on our Slack channel too. Over 800 users. The link is right here, jsjoin, jsjo.in. If you forget, it's really simple. If you have questions for this meetup, or questions you didn't get to ask, or because you couldn't make it, we'd love to have you just post it in our Slack group. So if you're a newbie, don't worry. It's a good place to go. There's a lot of great engineers all connected around LA and Orange County, so I hope to see you there.